Assalamu alaikum. Today we are discussing group 1A elements for F.Sc part 2. We had already discussed that S block elements comprise of two groups, group 1A and group 2A, and we already know that groups are vertical columns of elements. Group 1A of the periodic table, it is present on extreme left of the periodic table, and it includes the elements lithium, sodium, potassium, rubidium, cesium and francium. Lithium atomic number 3, sodium atomic number 11, potassium atomic number 19, rubidium atomic number 37, cesium atomic number 55 and francium atomic number 87. These elements are known as S block elements because in them the last electron enters the s orbital and they have ns1 electronic configuration in the valence shell. They have only one electron in the s orbital. They have one electron in the s orbital. For example, the electronic configuration of lithium is 1s2 2s1. Electronic configuration of sodium is 1s2 2s2 2p6 3s1. The electronic configuration of lithium can also be generally written as electronic configuration of helium into 2s1. Helium has 2 electrons and it has 2s1 configuration. The electronic configuration of sodium can be written as a configuration of neon 3s1 into 3s1. Potassium has the configuration 1s2 2s2 2p6 3s2 3p6 and 4s1, or it can be written as argon configuration into 4s1. Rubidium has 37 electrons. It has configuration 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p6 and 5s1, or we can write it krypton configuration into 5s1. Cesium 55 has the configuration 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p6 5s2 4d10 5p6 and 6s1, and we can write xenon configuration into 6s1. Francium has the configuration with atomic number 87, having 87 electrons, has the configuration 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p6 5s2 4d10 5p6 6s2 4f14 5d10 6p6 and 7s1, or we can write radon configuration into 7s1. The configuration of lithium ends at 2s1, sodium 3s1, potassium 4s1 and so on. Therefore, we say that the general electronic configuration is ns1, and this n is the shell number and it increases as we move down the group. Now, the general characteristics of S block elements are general characteristics. First character is that they are silvery white metals. They are silvery white metals which produce ionic salts like NaCl. When these elements are exposed to air, they get tarnished, they lose their luster due to formation of oxides, they lose their luster on exposure to air and get tarnished. Due to formation of superficial oxide layer. Second property is that they are soft metals and can be cut with knife. The general trend is that as we move down the group, the softness of these elements increases. For example, lithium, which is present at top of the group, is difficult to cut. Sodium can be easily cut, and as we move down to the bottom where cesium and francium are present, cesium and francium are creamy in nature. They are so soft that they are creamy in nature. Third property, they form unipositive ions. For example, by losing the valence electron, such as sodium plus 1, potassium plus 1, cesium plus 1. Fourth, they are highly reactive and react with air and water. That is why they are usually kept immersed in kerosene oil. Either they are kept immersed in kerosene oil like lithium, sodium and potassium, or if they are more reactive, then they are kept in sealed tubes like cesium and francium are very much reactive. That is why they are kept in sealed tubes. The fifth property is that their carbonates, sulfates and phosphates are soluble in water. Sixth property, these elements are less dense than water. Their density is less than water. That is why they float on the surface of water. They float on the water surface due to low density. These are some of the properties of the alkali metals. Now we discuss trends in physical properties of S block elements or group 1A elements. Trends in physical properties. How the physical properties change as we move down the group. Trends in physical properties of group 1A. The first property which we study is the atomic radius. A rough definition of atomic radius may be as the distance between nucleus and the valence electron is known as radius of the atom. It is rough definition, however we can consider it. We had drawn the electronic configuration of these elements, and it was that lithium has the configuration 1s2 2s1. It has two shells K and L. When we move towards sodium, atomic number 11, it has the configuration 1s2 2s2 2p6 3s1. It has three shells K, L and M. And as we move towards potassium, atomic number 19, it has the configuration 1s2 2s2 2p6 3s2 3p6 and 4s1. It has four shells K shell, L shell, M shell and N shell. Thus it is clear from these configurations that as we move down the group 1A, shells are added successively at each step, and it shows that the atomic radii increase down the group. The second property of these elements is ionization potential or ionization energy. Ionization potential is the energy which is required to remove an electron from an isolated atom or gaseous atom in its ground state and produce positive ion or cation. If we have a metal atom in gaseous state, we provide energy E to the metal atom and we get positive ion in the gaseous phase with the loss of electron. Then this energy which must be supplied is known as ionization energy or ionization potential. It is expressed in units of kilojoule per mole or it is expressed in units of electron volts. We had previously discussed that ionization energy is directly proportional to nuclear charge. Greater the number of protons in the nucleus of an atom, higher will be the ionization energy. And we had already discussed that ionization energy is inversely proportional to atomic radius. As the atomic radius increases, ionization energy will decrease. Now in case of group 1A elements, when we move down the group from lithium to sodium, potassium, etc. till the end, lithium has 3 protons, sodium has 11 protons, potassium has 19 protons, etc. The nuclear charge is increasing. The nuclear charge increases. Therefore, we expect that the ionization energy will also increase, but on the contrary, the atomic radius increases down the group, and increase in atomic radius will decrease the ionization energy. Now, in this case, the increase in atomic radius is the dominant factor over the increase in nuclear charge. That is why, as the atomic radius is a dominant factor as compared to nuclear charge, that is why as we move down the group, the ionization energies of group 1A elements will decrease from lithium to cesium and francium. Cesium and francium have the lowest ionization energy. Their electrons can be easily ejected. That is why they are used in photocells. A small amount of light when falls on these solar cells, then electrons are ejected from these elements called photoelectrons, and as a result photocurrent is produced. The third property of these elements is the electronegativity. We had defined somewhere electronegativity is the ability of an atom to attract the shared electron pair towards itself. For example, in HCl, chlorine has a greater electronegativity than sodium. So, electronegativity is the ability of an atom to attract the shared electron pair towards itself in a covalent bond. Now, electronegativity is inversely proportional to atomic radius. So, when the atomic radius increases down group 1A, as the atomic radius increases, therefore, the electronegativity of these elements will decrease. Next property of these elements is density. Density of the elements. We know that density is mass per unit volume. If the mass increases, density will increase, and if the volume increases, density will decrease. Here we have two factors, mass and volume, but as we move down group 1A, there is a greater increase in mass as compared to volume. Mass increases to a greater extent as compared to volume. Therefore, the density of the elements increases down group 1A. However, the density of potassium is less than density of sodium. It may be due to greater increase in volume of potassium as compared to mass. That is why the density of potassium is less than sodium. Next property of these elements is melting point and boiling point. We know that as we move, we had already discussed that as we move down the group, the softness increases. And it clearly indicates that as we move down the group, the attractive forces between metal atoms are also decreasing. That is why it will be easier to separate the atoms, and the melting point and boiling point will decrease down the group. The next property is electrical conductivity and metallic character. As we move down the group from lithium to francium, we had already discussed that the atomic radius increases due to successive addition of new shells at each step. The valence electrons are moving away from the nucleus and they are becoming free. Metals are the substances which have free electrons, and as we move down the group, the valence electrons are becoming more free as they are going away from the nucleus. Thus, the metallic character will increase down the group, and the electrical conductivity will also increase. Allah Hafiz.